Hello and welcome to this course on communicating with data in the Tidyverse. My name is Timo Grossenbacher and I'll be your instructor. Now, you can't see me. That's why I included a picture of me. I work as a data journalist, who is basically someone who tries to find stories in datasets. If you want to see concrete examples of my work, the R code I write, go to srfdata.github.io. You see, I use a lot of R code at work, and naturally, communicating results is an important part of it. And communicating is also part of the Tidyverse Paradigm, which you have seen in previous courses covering the Tidyverse. Actually, it's the last step in the data science workflow. Sometimes this step is a bit underestimated, but think about it. Your efforts might go completely unnoticed if you don't accurately and attractively communicate them. So we're not talking about exploratory visualization. We're talking about the communication of the most important points of your data science analysis. In this course, you are going to create the plot you see on the left side. Guess what? You're going to use ggplot2 for that, and only ggplot2. You already know this package from previous courses, but you probably didn't know how it can be tweaked and customized like this. Actually, this is what the plot looked like before applying a custom look to it. The end result is not only easier to read and understand, its aesthetics are also different and, as I would argue, more appealing. Apart from that, you're also going to create a report where you show the findings of your analysis and embed your graphics. This is another cool thing about R. It can be used to automatically create custom and professional looking reports like this one. Here you're going to learn how to do this. Throughout this course, you're going to work with two different datasets from the International Labour Organization, the ILO. Both contain indicators that are concerned with the international labor market. The first one gives working hours per week since 1980 for different countries. Each row in this dataset represents the amount of weekly working hours per year per country. The other dataset you're going to use contains another indicator, the so-called hourly compensation. Basically, it's the amount of compensation, that is, wages but also other benefits employees get for each non-working hour. Also in this dataset, each row represents the amount of hourly compensation in US dollars per year per country. So for example, in 1980, people in Australia were given 8.44 US dollars of compensation for each non-working hour. As a first exercise, you are going to combine both datasets into one. So each row shows both indicators for each country and each year. For this, you're going to use the inner join verb, also called function, from dplyr. So with the inner join function, rows from two datasets are matched based on a common key. Rows that are not contained in both datasets are lost in this operation, so only matching rows are retained. Look at the example here. Only rows 1 and 2 are retained because their keys exist in both data frames. Now let's try this out and use the inner join function to match both working hours and hourly compensation for each country and year.